So the next speaker to join us is Susan Forney. Susan is a network engineer from Hurricane Electric, and she's here to talk to us about IPv6 adoption over internet exchanges. Susan?
Hello, it's good to virtually be with everyone. Unlike many people, I'm actually giving this presentation from Boston, where the meeting was supposed to be held before we had to have it virtually. So I actually did get to realize my dream of presenting in Boston at NANOG, even though technically I'm in Dedham. So very happy to be here today. So first, I would like to start my presentation by giving a little pro IPv6 disclaimer. Hurricane Electric has worked to advance IPv6 deployments globally and is a strong advocate of IPv6. We started routing IPv6 on our network in 2000, and we received our first IPv6 public allocation in 2001. We completed a native IPv6 conversion in 2007. We peer with more ASNs over IPv6 than any other network. And if you're wondering how many that is, it's 5,229 today. We also peer with more ASNs over IPv4 than any other network, but today's talk is about IPv6. IPv6 adoption is important because now that IPv4 is depleted from 2 of the 5 RIRs, which of course are Aaron and Ripe, with LACNIC scheduled to or projected to join them in August, it's probably time to take a look at how internet exchanges have progressed in operating and deploying adopting IPv6. I started out with a couple of basic assumptions. First, that internet exchanges are historically where we grow the internet. As internet operators, internet exchanges have been where we drive change. And then secondly, that if we were increasing IPv traffic across exchanges, we would start that by increasing IPv6 peering. The development of internet exchanges has shaped the industry, and here are a few IPv6 and internet exchange facts to keep in mind. First, 27% of all existing networks advertise IPv6 prefixes. And of the 688 internet exchanges worldwide, 20 new internet exchanges were formed in 2019. Clearly, internet exchanges are still a vital part of the networking landscape and necessary. As a matter of fact, already this year, 3 new internet exchanges have formed. And the newest one in North America is Quad City IX in Davenport, Iowa. I'd like to give a shout out for them for just joining us. So they're the newest ones. Also, peers are more likely to route IPv6 statistically if they participate in an exchange. So to get started with how exchanges are deploying IPv6, first, I decided to start looking at the top 20 internet exchanges by members, just to get an idea, give you an idea of how big internet exchanges impacts are. The largest internet exchange in the world is BRX in Sao Paulo, and they have over 1,500 members. So there's obviously a lot you can get done there in terms of reducing latency and increasing throughput. The next largest one is in Europe, DKIX Frankfurt. AM6 is there, along with Lynx, one of the very first internet exchanges, Data IX, EPIX and Katowice, Moscow IX, France IX, NLIX in the Netherlands. Again, Netherlands also a big booster of the internet and have a lot of busy exchanges. NAP Africa in Johannesburg is the 10th one, the 10th largest in the world right now. France IX and Equinix Paris, PTT in Rio de Janeiro, EPIX in Warsaw, Equinix Singapore, NE2 in Los Angeles, Equinix Ashburn, the 6th, PIDERX and HKIX in Hong Kong. Those are the largest internet exchanges in the world. You notice that of the large internet exchanges, the bulk of them have between 300 and 400 members. And how I started thinking about this talk actually was I was turning up some new peers in European exchanges. And these particular networks had referred me to their peering DB page to get the information for setting up the peers. And so although they had IPv6 addresses listed there, and I turned them up, and when they didn't come up, I contacted the peers and said, hey, the v4 came up, the v6 didn't. And they said, oh, well, I don't really have IPv6. And I thought, well, that was kind of weird. You know, you have an IPv6 address, but you're not peering over it. And that's when I started wondering how prevalent that really was. And that's how this talk got started. So the first thing I'd like to look at is the global trends. So there are a lot to absorb. And I thought that if we took a look at the regions, that this would be a lot easier to figure out what actually was going on with internet exchanges. I thought that we'd take a look at the regions of the world and compare them to North America, since we're at NANOG. And how I measured this progress was I looked at the number of IPv6 addresses that are listed or assigned for each exchange to each member. And then I looked at how many of those IP addresses were actually reachable. And then I compared how many reachable IPv6 addresses against how many reachable IPv4 addresses there were on each exchange to determine who was able to peer over the IPv6 exchange. And the reason why I decided to do this was because almost everybody peers on the exchanges with IPv4. And it didn't seem reasonable to compare to the number of just the number of listed exchange IP addresses that were assigned. So it seemed more logical just to compare to, of the people who are actually peering on the exchange, the people who have active IPv4 addresses, how many of them have reachable IPv6 addresses, which is where I got the bulk of this data. And again, this is kind of a quick snapshot of how I did that. I gathered the IPs, I looked at how many were reachable, and then I calculated the ratio. And in the graphs, I expressed the ratio as a percentage. So Europe has literally led the way in forming internet exchanges, so I'm going to start looking at them first. A little European IX trivia includes that of the 688 internet exchanges I previously mentioned, 261 of those are in Europe, which is over a third of the exchanges in the world are in Europe. The first internet exchanges in the world were established in Europe. And peers are more likely to have both an IPv4 and IPv6 peering session on the European exchange. They're big boosters of IPv6. So the first exchanges I looked at were the top 10 exchanges in Europe, and ePix and Katowice is the top one, has the most assigned IP addresses, a little over 100%. And you say, well, how can there be a little over 100%? Well, that's because in a lot of exchanges, a network might have only one IPv4 address, but they might have 2, 3, 4, 8 IPv6 addresses. So the number of the assigned IPv6 addresses can actually be higher than the number of assigned IPv4 addresses. Equinix Paris, DKIX Frankfurt, and France IX, all super close, Data IX and Moscow IX, all super close to 100%. ePix Warsaw, coming in just a little bit farther, and then NLIX is the lowest with about 79%. So, most places they have, if you have a v4 address, you have an assigned v6 at European Exchange. But if we go down and we look at now, how many of those IP addresses that were assigned are actually reachable? It's a little bit different picture. The blue bars are still the number of assigned addresses, but the orange bars are the number of addresses that are actually reachable on the exchange. And like, for instance, where Katowice had one of the highest number of assigned IPv6 addresses, they actually have one of the lower numbers of reachable IPv6 addresses on the exchange that were actually, you could actually ping. Same thing in ePix Warsaw, Data IX, France IX, Moscow IX, a little bit lower. Bringing in the top honors was NLIX and Blinks and Juniper, or Blinks, the Juniper LAN, and AM6. Also, DKIX Frankfurt doing very well. All of them, between 80, 85%, maybe some up to 90% of reachable IP addresses, but not what their initial numbers would have suggested, where just about everybody on the exchange has an IPv6 address. So while Europe is senior among IXs undisputably, Africa could be kind of characterized as the new kids on the block in internet exchanges. Those networks are expanding across the African continent rapidly, and new exchanges are developing everywhere, helping those networks across that continent be more diverse and get better throughput. And just because they're new doesn't mean they're small. NAP Africa and Johannesburg just cracked the top 10 of the largest internet exchanges in the world. So they're very busy. And Africa's internet infrastructure is very diverse. There are 54 countries in that continent, and they're developing very rapidly and turning up at exchanges. So let's take a look at where they are as far as assigned IP addresses. So then again, if we look at this graph, we see that most of them are between 90 and over 100%. NAP Africa has about 112%. Then I looked at NAP Africa in Cape Town, NAP Africa in Durban, DINX, the Durban IX, KIXP in Nairobi, Kenya IX, and Djibouti, and JINX. And I apologize for any of the names I am massacring, because I'm not sure how to pronounce all of them. Anyway, so all of those have a high amount of assigned IP addresses. But then we go down to the next slide, and we see that, not quite that far, just the next slide. Right. We see that the reachable IP addresses aren't quite as good. The highest is JINX with 79%, and the lowest is Cape Town NAP Africa with just 22%. And in some respects, when you're starting out with the internet, that is kind of to be expected, but the numbers could be obviously a lot higher. So the next region I looked at was Asia Pacific. It's a broad region with unique challenges, different challenges than the other 4 regions we're looking at today, because a lot of the region is widely dispersed throughout the Pacific Ocean, meaning that they have to be connected via a lot of transatlantic cables. And so internet exchanges, keeping local traffic local, can be very important. Also, Asia, big part of the region, the cities have very dense populations. IPv4 addresses have not been plentiful in Asia, and they have embraced IPv6 because it's what is available to them. So they're good adopters of IPv6. And Asian ISPs have obviously embraced that. So let's take a look at where they are as far as assigned IP addresses. And again, we see that you can see most of them have IPv6 assigned. And I was looking at in Asia, JPNAP, HKIX in Hong Kong, JPIX in Tokyo, Equinix Singapore, TPIX in Taiwan, KINX in Korea in Seoul, Megaport in Sydney, Megaport in Melbourne, Auckland IX, and also Philippines IX, which mostly I looked at because Hurricane just turned up there. So we were available so I could see what was going on there. And then if you look at the next slide, you can see that it's, again, pretty impressive, honestly, for the Pacific region. Most of these IXs have high penetration of the IPv6, assigned IPv6 addresses are available to peer on. The Philippines IX is not as high. It's only about 35% Auckland IX is a little bit lower. Melbourne and Sydney are a little bit lower, but most of the other IXs are very active peering environments and in IPv6, and a lot of people participating. So Asia is, as expected, is pretty good. And then, because we're NANOG, I saved the North American Internet Exchanges for last. So Aaron was the first RIR to exhaust its allocation. So let's take a look at that, lit a fire under anybody in the North American exchanges. So again, we're going to look at this slide that tells me which of the top exchanges I looked at. And in the US, NE2 Los Angeles was the one that had the highest penetration of assigned addresses. Then we looked at NYIX and the 6 in Seattle, DKIX New York, Equinix San Jose, the Toronto IX, DR Atlanta, Equinix Chicago, Equinix Dallas, and Equinix Ashburn. Those are the large IXs in the US, and those are the ones we looked at. And then if we go down to the next slide, we see that, yeah, you know, it does seem like it is pretty impressive. The lowest amount of IPv6 or reachable addresses was in Toronto at 57%. So by far, you know, the difference between, or the lowest, you know, on their 57% is pretty good. It does show that IPv6 is being deployed pretty enthusiastically in these exchanges, and that there's a lot of participation. It's high in most of those exchanges. So when I was doing another talk last year, I was doing some research on the percentage of our population that are internet users. And what I discovered was that there definitely is a correlation between how high a saturation you have of internet users in your population versus how much IPv6 is deployed. And this would explain a lot of the differences that we saw in the in Europe and Asia, and to a certain extent, not so much in the US, because I'm not really sure what happened in Toronto, because Canada has pretty good internet participation. But the maybe they just need to work harder. But it does. There is a correlation, so it would explain that why in the Philippines the IPv6 was a little bit lower, and why in some parts of Africa the IPv6 participation was a little bit lower, because the percentage of the population that are internet user in those places is a little bit lower, especially compared to places like Europe. And that has an impact on development or deployment of IPv6, because when you're just trying to get network started, obviously everybody's on IPv4, that would be your priority. So it means that, there is kind of a reason why that happened, but it still means we have a lot of work to do in those areas, because we still have to deploy IPv6 everywhere. So overall, I guess what these net figures show you is that you can assign a network an IPv6 address, but you can't make them peer. Based on what we saw, though, I think a few assumptions still seem reasonable. IPv6 routing is actively encouraged on internet exchanges. The internet exchanges deploy IPv6 on their route servers, and many of them assign IPv6 space automatically with the IPv4 addresses. And that's an important partnership in deploying IPv6, and they really should be recognized for how hard they work at it. A large percentage of peering networks are routing IPv6. And on most exchanges, the number of networks is higher than the number of networks participating in routing IPv6 is higher than the global average of 27.3% on all ASNs. So that shows you that internet exchanges are, where IPv6 is being deployed and where it's being promoted. And if a network isn't peering over IPv6, it's probably because it does not have IPv6 deployed. If you average all the IPv6 deployment statistics I showed, I averaged on all the internet exchanges how many networks were reachable via IPv6, and it came to 54%. which is about double the global average. So again, proof that those internet exchanges are actively participating in IPv6 and making good progress. So next slide here. ARIN exhausted its IPv4 allocation in September of 2015, and RIPE just distributed its last allocation last year in November, and the remaining RIRs don't have a lot of time left. So if you're wondering, why you should worry about this, there isn't going to be a lot of IPv4 address available for RIRs to allocate. And then you're thinking, well, I can NAT. Well, yes, you can NAT, but CGN solutions still require additional IP space. Unless your network is not going to grow at all, NATing won't solve your problems. You still will need additional IP space. And yes, you can still buy IP addresses. Now, IP address, the current pricing is $21 per IP address for a /24, 23, or 22. And this is up a bit because once upon a time when we weren't really selling IP address space, there was a question on how much an IP address was worth. And in 2011, Microsoft kind of answered that question when it bought 666,624 addresses for $7.5 million from Nortel. And that put that figure at about $11.25 an IP address. And that gave the answer to how much an IP address costs. Obviously, in the last 9 years, that price has edged up a little bit. Now it's almost double. Depending on who you believe, there are people who think that IP address prices could double again over the next 2 years. There was a recent development saying at the end of 2019 saying that the U.S. Department of Defense was planning on selling over 200 million IP addresses. And I believe that was the equivalent of about 12/8s. And they have indicated that they would not sell them all at once and that they would be selling them in large blocks over the next 10 years. That may or may not have an impact on the market. It's definitely good news for people who have lots of content, or maybe cloud providers who need lots of IP space and are wondering where they're going to get it. So that might give them a little bit of a reprieve. But for the rest of the networks, they probably still are going to have a hard time getting their hands on IPv4 space. And to take a look at whether or not this is actually causing any pressure on the market, I looked at IPv4 transactions since they seem to be increasing year over year and from the RIRs. And if you look at this graph here, which I got from Jeff Houston on his site, you can see that there is definitely pressure on the lack of IP4 addresses, which is reflected through the amount of transfers. The blue line is ARIN, which has just continually gone up. The gray line is RIPE. RIPE had an anomaly where they changed their policy, which affected how many transfers happened in 2015 and 2016. So it's not like the 2015 exhaustion of ARIN had any big definite effect on RIPE. It's more of the policy change. But still, you can see that the trajectory is up. It mirrors ARIN. And APNIC has been pretty steady. LACNIC has been pretty steady, even though they're about to run out of IP addresses. But this does indicate that, especially since most of the ARIN has the most IP addresses to transfer around of any of the RIRs, and it does indicate there is some pressure via IPv6 and scarcity of IPv4 addresses. So I think that it's clear that the increasing number of transactions is a reflection of demand, and demand will result in increasing the price of IPv4 space. So while it might, I don't know what your odds are of doubling it, but definitely the price seems like it's going to go up. And soon, the availability of IPv4 addresses will only be through your friendly IP address brokers. And as more users are added to the internet, demand for IPv4 addresses will rise. The one thing you have to remember is that not everybody in the world is on the internet even right now. And because of that, as more users are added, more IP addresses are needed. Marketing a transfer of legacy IPv4 blocks means most networks will be able to get IP space for the foreseeable future, but demand and speculation are going to continue to put pressure on price. And to give you an idea of how that might happen, higher prices are good news for IPv6 deployment, but not for all the obvious reasons. You're thinking because people would have to pay more. It's also because it's driven mobile providers to and a lot of end user service providers to IPv6, so they avoid the problem of where are they going to get IPv4 addresses for all of their users. If you as a provider make your service available over IPv6, you don't have to rely on 6 to 4 tools, and you can access those users directly. And as you can see, the number of people who are accessing the internet over mobile devices is increasing. It went from about 35% of users in 2015 to nearly 54% of users in 2019. So the trend is up. More people are accessing the internet from their phone or from their mobile device. And so if you want to reach them and you want to reach them more efficiently, being on IPv6 is in your best interest. So it's obvious that more appearing on the internet will drive more IPv6 deployment. What might not be as obvious to network operators is that encouraging the growth of IPv6 networks works in favor of those of you who just don't want to get off of IPv4. And the reason for that is because when more traffic moves to IPv6, it lessens the demand for those IPv4 resources. So if you were hoping to be able to hang out on IPv4 forever and not have to worry about where your IP addresses were coming from, then the best strategy for you is to encourage everyone that you know to peer over IPv6. So there's more IPv space for you. And so, but if you do not deploy IPv6, it puts pressure on the IPv4 supply, and that increases prices and the cost of operating networks. So if you want to keep prices down and your cost of your operating network down, then you want to be on IPv6. And if you don't want to be on IPv6 and you want to have IP space and lower prices, then you need to encourage everyone else to do it. So, win-win either way. Whether you want IPv6 or not, you should be encouraging everyone to be on IPv6. So, if you think about more networks need to route traffic over IPv6, you can do something about it. When you start a new peering arrangement, ask the network for their IPv6 information and turn up IPv6 peering at the same time. Just because someone didn't offer you their IPv6 addresses doesn't mean they aren't using them. Frequently, when I turn up peers, they don't volunteer the IPv6 information, and I'm from Hurricane Electric. So it never hurts to ask to get that IPv6 address. It takes very little effort to turn up the IPv4 session along with the IPv6, so you might as well do it while you have them there. Now, after you get that session up, advertise your IPv6 prefixes and ask other networks to advertise theirs. Frequently, when I turn up an IPv6 peer, I go back and I check, and I see that they aren't advertising any prefixes to us. And now sometimes, of course, when you turn up a peer, you don't necessarily start advertising your prefixes. Maybe your policy in your network is that you have to wait for a maintenance window before you make a technical change to the network, and advertising prefixes a change. So you might not see that right away. But if you go back, like I have with some peers, and you see after 6 months, these people still are not advertising their prefixes to you, it is time to give them an email or a call and ask them to do that. Just think of it as peer pressure and make sure that you are getting those routes from all those people where you've turned up those ports. Because after all, if you if you have that port on the internet exchange, you might as well get as much traffic across it as possible. You're already paying for it, so make sure you get IPv6 traffic on it and get that port used. So, in summary, what I'd like to remind you is that IPv6 participation on internet exchanges is better than the global average of 27%, as we said, about 54%. So things are looking good. Things are looking pretty good on IP exchanges, while there's room for improvement. And while IPv6 adoption continues to increase, IPv4 is here to stay for the foreseeable future. And no matter what your protocol politics are, increasing peering over IPv6 will help you meet your objectives. Thank you very much for your time. Do you have any questions?
Thank you very much, Susan. We've got a couple questions that have come through for you. First one on the list, is there a complete list of IXs, perhaps a list of IXs with IPv6 enabled route servers?
Yeah, there is a list that several people provide a list of internet exchanges. Hurricane Electric has one at bgp.he.net. And if you look at the exchange report, you'll see a list of all of the exchanges that we know about, and that we have information about what they have a route server or not, and information, all their IP space and who's at the exchange. So if you take a look at that, that would give you a good idea.
Awesome. Next question up. How did you determine reachability on the exchanges? ICMP?
Kind of. The reason why I did this talk was because Hurricane is at all of those exchanges, so it gave me the opportunity to be able to look at them. And instead of ICMP, what I did was I used the ARP table and the neighbor discovery table. I pinged all of the addresses in the exchange before I took the ARP table or the neighbor discovery table, and then as soon as pings finished, I just dumped the table and took a look at what was there. I thought that was better than ping in case somebody was blocking. Some people block pings, so just to be on the safe side, if they're in the ARP table or they're in the neighbor discovery table, I knew they were reachable.
Very good. Next question up. We did not see India and China in your presentation. What's the situation in those countries?
Well, again, the reason why I did this talk was because we're in a lot of internet exchanges. Unfortunately, Hurricane does not have a presence in India or China. We are in Hong Kong, but I couldn't really pretend that I could characterize China from just a presence in Hong Kong. So that's why I didn't talk about those particular countries.
Reasonable enough. Let's see, what else we got? Have you seen any V6 peering with RFC 5549 yet? V4 NLRI with V6 next hop?
Not me personally, no, I haven't. If it's V6, Hurricane peers with it, so it's possible that we're doing it someplace, but I personally have not seen that.
Gotcha. Here's a great one. How can we expect end users to adopt V6 when the core providers are not offering full IPv6 reachability yet?
Well, I think that's kind of a chicken and the egg question. At the end of the day, if you build, they will come. And, all of us are working very hard to create a complete, reachable V6 internet for everyone. And the more places that you turn up V6, the more compelling you make it. If we all work together to build it, it's going to happen. If we sit on the sidelines and wait for it to happen, it's not going to happen. So the big point of this talk was to, point out that we're doing very well on the inter exchanges. They provide a environment for us to get this promoted, but it isn't enough. Where there's more that we can do. So we could do better.
Well said. And final question we have that came in. I may have missed it in your slides, but how is the V6 adoption vary by country?
Vary by country? Well, it does seem to me that well, I was talking about in that one slide about the internet, the penetration of internet and adoption of internet in a country versus the amount of V6 I saw in the exchanges in those regions. There seems to be a correlation in that, and I think that's because the if you're just trying to get the internet up, obviously you need IPv4. That you've got to have that. You're not going to connect to everything, so that is everyone's priority. And so you see V6 lag a little bit in those places, and I think that's probably why.
Indeed. Well, that seems to be all the questions we have for you. Thank you very much, Susan. Excellent presentation as always.
Thank you very much for having me.
You bet. And thanks everyone for attending.